Okay, now we'll get to the little more complicated cases. So for example, complete dominance. You have one allele, that's the allele that is the dominant allele, that is enough to catalyze a reaction. Or if that allele is preventing a reaction from happening, and having one allele preventing, that's also the dominant allele. So this would have to do with if the enzyme is catalyzing or preventing, but as long as having one allele is enough to cause a phenotype, that is the allele that we call dominant. So let's see in the case of Mendel's peas, what he saw. So here's some background so that you can understand this. The pea seed, so it has a cotyledon membrane. So imagine the seed, there is a membrane around the seed that is green. And it's green because it has chlorophyll. Or that cotyledon membrane is colorless because the chlorophyll was degraded. And the endosperm, which is underneath the cotyledon, is yellow. So just think the endosperm is yellow and the cotyledon membrane is wrapping paper. So you either have green wrapping paper or you have colorless wrapping paper. So if it's colorless, you can see the color of the endosperm, that's yellow. Okay, so in here, and this is wrapped with colorless wrapping paper, and this one with green wrapping paper, so it will look green. So far so good? So now you're like, okay, but what makes it colorless versus green? And here's a bunch of reactions that you might get scared when you see the pathway, but you don't have to look at details of the pathway. Maybe you're thinking, okay, mostly I'm interested in the genetics part, so I'll point out to you what's the interesting part. So there is a gene that's called stay green or non-yellowing. It's two names for the same gene. I think it was found by two different people. So that gene encodes an enzyme that is the magnesium dechelatase. So it stops the chelation of something. So you're like, okay, what's that do? So here's the pathway. There is chlorophyll B, which then there is this enzyme chlorophyll B reductase. It changes it into whatever this is, that. And then it's almost chlorophyll A, but not quite. There's some other enzyme that changes chlorophyll B to chlorophyll A. So plants actually have both of these. And then this is where the magnesium dechelatase comes in. So it does this function, and then if the pathway, if all of these guys, so these are all enzymes that are making these conversions, if they're all working, in the end, this thing is colorless. Okay, so if this guy is working, this will be colorless. Well, provided all of these are also working. Now, if it's not working, this pathway stops here. So a functional enzyme will destroy chlorophyll. Well, it will promote this step so that it can get to the end of destroying chlorophyll. And then if it's not functional, then what happens? Let me set a poll for that.